All right, here's some tips on solving problems. Many students have trouble solving story problems or word problems. Well, physics is all story problems or all word problems. So here are some tips to help you get through these types of problems. First of all, understand the problem. So read the problem carefully, and as you're reading, write down the given information in symbols and write down what was asked in symbols. So don't just write the numbers down. Write down the symbol for the quantity, then write down, if you're given a number for it, write down the symbol equals the number and the unit as well. Don't forget to include the units. It's very important. And then write down in symbols what you are asked for. Then devise a strategy or a plan. The path to the solution may take several steps. In fact, it usually does take several steps. Most of the time, you cannot just write down one equation and get the answer. You may have to do several steps. Number 3, first principles. Remember that the equations that we use are expressions of physical principles. We use the language of mathematics and physics. In fact, all the hard sciences, we use the language of mathematics. So it's important to recognize the equations and what they represent, rather than just look at them as things to plug numbers into. So we try to do everything on first principles. So if we're learning about Newton's second law, so it's important to understand what Newton's second law is and the equation that represents Newton's second law. So that's what we mean by a first principle. So solving problems involves translating physical principles into the language of mathematics. But you should be able to look at an equation and determine what physical principle it represents. So a common failure is a misapplication of the physical principle. Many students, when they try to solve physics problems, so they're given a physics problem and they do the first step. They read it carefully, they write down the given information in symbols, they write down what was asked for in symbols. Then they'll just start thumbing through the text and see if they can find an equation that has those symbols. And then they'll just pull that equation out that has, well, this equation's got all those symbols in it. I'll just plug the numbers into there and see what I get, and then check to see if my answer is right. And if the answer comes out right, they say, oh, great, I solved the problem, and have no idea what they just did. Or they plug the numbers into the equation, they get the wrong answer, and they think, well, I must have used the wrong equation. Let's see if I can find another equation that has those symbols and try that one. And so they're just randomly trying equations, plugging numbers in until they get the right answer, and then move on without having any idea what you just did. So this third step is very important to understand what's going on. So you want to determine what physical principle the equations represent and apply things from first principles. So starting with first principles, you don't have to memorize or learn so many different equations, right? You can solve everything from the first principles, and there are very, very few equations you actually have to use. So I have heard students complain before, oh, physics, it's just so many equations, I can't keep track of everything, there are just so many equations. Well, there really is not so many. Now, you may see so many different equations because people will derive different steps. But if you start from first principles in solving your problems, there really are not very many equations at all. The additional equations come from doing the different steps that it takes to come up with the final answer. But those are not equations that you have to try to memorize or learn. You learn the first principles and then you can solve all of the problems. Also, draw a simple diagram. You don't have to be an artist. Simple blocks and stick figures do just fine. A diagram will greatly help you to visualize the situation and avoid confusion when different elements are acting together. So this is very important. Many, many times. I've been teaching this class for many years. And I have a hard time getting students to draw a simple diagram. So many students, when they get their physics problems, the first thing they want to do is just start plugging in numbers and seeing what they get out without trying to understand what's going on. Draw a simple diagram. You don't have to be an artist, but don't be afraid to start with just drawing a simple diagram on scratch paper. That can really help you see where you have to go to find the answer. All right, next, number 5. Check to see that the units are okay. You want to make sure your units are consistent, so you may have to make some conversions. So it may be useful to keep the units with each quantity to see that the result is consistent with the units. So for example, you may be given a velocity in meters per second, or you may be given a velocity in kilometers per hour. Well, if you have one in meters per second and another one in kilometers per hour, they're not compatible with each other. So we have to use a consistent set of units. Or you might give a speed in kilometers per hour and an acceleration in meters per second squared. Again, you have inconsistent units. So you want to get all your quantities in a consistent set of units before you start trying to solve the problem. And then finally, look at your answer and think if it's reasonable. Is the answer too large or too small? Do you have the correct sign? Are the units what you're at the correct units? So for example, if you're asked to find a speed and you get an answer in distance, or such as meters with no time in it, well, you know distance is not a speed. Or if you're asked to find an acceleration and you get something with kilograms in it, well, kilogram is a measure of mass. Acceleration does not have any mass in it, so you know that that's not correct. Also, is it too large or too small? I remember giving a quiz one time where we were asked to find the area of a compact disc, and someone gave me an answer of an area about the size of the state of Arkansas. So if you get an area the size of the state of Arkansas for the area of a compact disc, I don't think that answer is going to be correct. And it should be very obvious by looking at it that it's not. All right, remember, in any problem, the units must be consistent. Now, you can multiply and divide quantities that have different units, but keep the units within the same system. So for example, speed could be written in meters per second, centimeters per second, or kilometers per hour. But try to keep all the units in the MKS system or all in the CGS system. We will primarily use MKS system, which stands for meter kilogram second. So make sure all your units are in the same system. Now, as I said in the first one, we can multiply and divide quantities with different units. But if we're adding or subtracting quantities, they must have the same units. So when we're adding or subtracting quantities, they must have the same units. Now we can multiply or divide quantities with different units, but not adding and subtracting. For instance, it makes no sense to add your mass to your height, right? If you try to add your mass to your height, that is meaningless. However, you can divide your height, divide mass into your height and get your height to mass ratio. Now that would mean something, but you cannot add your mass and your height together. Now, example, what is the result of this following sum? 25 meters per second plus 150 meters plus 2.5 kilograms plus 9.8 meters per second squared. What does that give me for an answer if I try to add those things together? What do I get? So if I try to add those things together, what do I get? I get nonsense. Absolute nonsense. It makes no sense to add 25 meters per second to 150 meters. That doesn't mean anything. Or add 2.5 kilograms to 150 meters. That doesn't make any sense. I'm adding a distance to a mass, or a speed to a distance, or a speed to a mass. I can't add things together that have different units because they are different physical quantities, and it doesn't mean anything. It's just nonsense. However, I do see this many times when students are first learning kinematics. Oftentimes I'll see people try to add speed and acceleration together, and that is nonsense. Alright, so what's next? Well, first I want to say a word about solutions manuals or looking up solutions using Google. Now these may be helpful if you get stuck, but don't rely on them exclusively. It's very important that you try to solve the problems yourself. This is how you practice. You cannot learn any skill without practicing. And working the physics homework problems is how you practice. So it's very important that you try to solve these problems yourself and start with the first principles. Don't just grab equations from the book and plug numbers into it and see if it gives you the right answer. Always start with the first principles. All right, so the next thing we'll do is we'll look at the kinematic equations, which are descriptions of motion. So first we'll learn how to describe motion and the equations that we use for describing motion, and then we'll look at some examples of motion in one dimension. So take a look at the next video that I've linked here. Hi, Dr. C here. I want to ask you to please help support this channel. There are links in the video description to Amazon.com. If you purchase any items from Amazon by entering through these links, I receive a small commission to help produce more content. There is no additional cost to you whatsoever. Also, please leave your comments, questions, or suggestions. Thank you for supporting this channel, and I hope you find it useful.